Today we are going to learn about operations in scientific notation. Let's have a look at adding or subtracting in scientific notation. The first step we need to do is to make sure that both numbers we are trying to add or subtract are the same power of 10. So in the example, 2.46 times 10 to the 6th plus 3.476 times 10 to the 3rd, we would notice that 10 to the 6th is not the same as 10 to the 3rd. So we need to make them the same. To do this, we would say 3 plus 3 is 6. So we need to multiply by 3 more 10s. However, we cannot change the total value of the number, so that means we're going to have to make our coefficient smaller. We're going to have to move our decimal to the left. So our new number is 0.003476 times 10 to the 6th, and both numbers now have the same power of 10. So we can move on to step 2, add or subtract the coefficients. So let's do 2.46 plus 0.003476. Now in this case, we get 2.4634. We're going to leave our exponent the same, so it's times 10 to the 6th. Finally, let's check and make sure our answer is in proper scientific notation. If we look at our number, for our coefficient, we have a single digit that is not 0 before the decimal. We also have this multiplied by a power of 10. So we are in fact in proper scientific notation, and we are done with the first example. Now let's look at the second example. 4.23 times 10 to the 3rd minus 9.56 times 10 squared. Notice how here, once again, our Now, let's look at multiplying and dividing in scientific notation. If you look at this example, we have 2.41 times 10 to the 4th times 3.09 times 10 squared. Remember, if there's no operation between parentheses, it's multiply. Step 1 is to multiply or divide the coefficients. Here, the coefficients are 2.41 and 3.09. When you multiply them together, you get the quantity 7.45. Make sure you remember how to do your multiplication and division using decimals. Then we're going to move on to step 2. Step 2 is to apply exponent rules to the power of 10. Remember, multiplication means you need to add the exponents. So if we have 10 to the 4th times 10 squared, we're going to get 10 to the 4 plus 2, or 10 to the 6th. And our final answer is 7.45 times 10 to the power of 6. In this example, we have the quantity 4.89 times 10 to the 7th divided by the quantity 2.74 times 10 to the 4th. So let's go through our steps. First, we're going to divide the coefficients because this is a division problem. 4.89 divided by 2.74 is 1.78. Now we're going to apply the exponent rules. Remember, whenever you are dividing numbers with the same base but different exponents, you have to subtract the exponent. So 10 to the 7th divided by 10 to the 4th is 10 to the 7 minus 4, which is 10 to the 3rd. And our final answer is 1.78 times 10 to the 3rd. I would like to add on one little extra step, and that's to make sure you are in proper scientific notation, because sometimes your denominator will be bigger than your numerator and you'll get a decimal, in which case you would have to change your answer to proper scientific. When you're multiplying, if the product of the coefficients is 10 or larger, you will have to convert to proper scientific as well.